are going to verify this is an identity. So they've given us sine alpha plus beta times sine alpha minus beta, and we need to prove that that really is equal to sine alpha minus sine squared alpha minus sine squared beta. So I'm thinking the first thing I ought to do is start with the left side and use the identities to change it to just alphas and betas instead of alpha plus betas and alpha minus betas, right? So basically the identities of this section. So sine alpha plus beta would be sine alpha cosine beta plus cosine, alpha sine beta, correct? So that replaces that thing right there, and these are going to be multiplied together. So now I need the other one that goes with that, and then I'm going to FOIL. This is going to kind of be ugly, but not too hard. Sine alpha times cosine beta. This time we do a minus. Cosine alpha sine beta. Any questions so far? This is just the left side of the problem. I'm ignoring the right side so far. Okay, so I just replaced these with the identities. Now what's the next step? FOIL. Good. So I'm going to go sine alpha cosine beta times sine alpha cosine beta. There's my firsts. So that gives me sine squared alpha cosine squared beta. Then I'm going to go outside sine alpha negative cosine beta, or negative cosine alpha, sorry. Negative sine alpha times, oh wait, that negative's already there. So sine times cosine makes it negative, and I'm just going to write cosine. There we go, sorry. And then cosine beta sine beta. That's kind of ugly, and I really could have noticed something and not had to write that out. Do you guys notice what I could have noticed? These are conjugates. Plus here, minus here. What always happens to your outside-inside terms with your conjugates? Yep. So we totally could have saved that effort. Here's our inside. Cosine alpha, sine beta. I don't know why I'm writing it in the order it's in. Really weird. But basically you've got a sine alpha and a cosine alpha and a sine beta and a cosine beta of each one in each one. So even though I've written them in different orders, they're the same thing. So they cancel. Then we do our last terms. So that is positive times a negative is a negative. Cosine squared alpha sine squared beta. Okay, so those two canceled out. And so I'm left with, let's just rewrite this, sine squared alpha cosine squared beta minus cosine squared alpha sine squared beta. Okay. Any ideas on what I can do next? Right now the problem has sines and cosines in it, right? And the final answer I'm looking for here when I verify this is just sines. So we did something similar to this the other day with the Pythagorean identity. We remembered that since sine squared alpha, or I'll just use an x so it's not alpha or beta, plus cosine squared x equals 1, that means that sine squared x equals 1 minus cosine. And what was the other thing we used? Sine squared, wait, other way around. Cosine squared x equals 1 minus sine squared, correct? So is there a way that we can somehow use this thing to change all the cosines to sines? Yeah, so everywhere where we have a cosine, we're going to do a 1 minus sine for that particular angle. So we have a beta here that we'll replace with beta, and an alpha here we'll replace with the alpha version, right? So sine squared alpha, we're not going to do anything with that. But cosine squared beta, we're going to replace with 1 minus sine squared beta. Then we have a negative. Then we're going to replace cosine squared alpha with 1 minus sine squared alpha. And then that's times the sine squared beta. Okay, now what? Should we distribute this and then distribute this? I'm thinking distribute. Okay, so sine squared alpha times 1 is sine squared alpha. And sine squared alpha times sine squared beta is a negative sine squared alpha sine squared beta. Okay, then let's distribute this sine squared beta through this, but I also want to include the negative when I distribute it. So it'll be negative 1 times sine squared beta. So that's just a negative sine squared beta, correct? And then it'll be a negative times times sine squared beta. So a negative times a negative is a positive sine squared alpha sine squared beta. Okay. Now combine like terms. What goes away? And that leaves us with sine squared alpha minus sine squared beta, which matches the other side of our problem. So we were able to do this just by working on the left side, which is good because I used up all the space.